Welcome to solverfy.
This is the answer to Chapter 19, problem number 23 from the Smith Organic Chemistry textbook. And this problem says, draw the positively charged, neutral, and negatively charged forms for the amino acid glycine. And we're asked which species predominates at pH 11 and which species predominates at pH 1. And so the neutral form of glycine is going to be the form in which we have two charges. So at a neutral pH, glycine is going to exist as the Zwitter ion, so a positive charge and a negative charge. And so remember that the side chain on glycine, there isn't a side chain, there's just a second hydrogen. And so the positively charged form of glycine is going to be where we have, instead of the carboxylate ion, we have the carboxylic acid. And we will have our charged amine, so the H3N plus. And then obviously the two hydrogens are still there. And the negatively charged form of glycine is going to be where we do not have a charge on the amine, and the carboxylic acid has been deprotonated. So here are our three forms of glycine. And so this is going to be the neutral Zwitter ion. And then to think about which of the other two is going to predominate at which pH, we need to think about what the pHs mean. So at pH 1, that's a very acidic pH. And so what that means essentially is that we have a lot of H pluses floating around in solution. And so since we have a surplus of H pluses, the nitrogen is going to have lots and lots of opportunities to grab an H plus and to become H3N instead of H2N and to become positively charged. And so at pH 1, that is the form that's going to predominate. So conversely, at pH 11, we have a real lack of hydrogen ions in the solution. So the way that I think about that sometimes, especially in this context, is that the solution is sort of hungry for hydrogen ions. And so since the solution wants to increase the amount of hydrogen ions that are in it, it's going to snag the hydrogen from the carboxylic acid. And so at basic pH, the carboxylate version, the negatively charged version of this amino acid, is going to predominate. And another way to think about that might be that systems want to establish an equilibrium. So how is the amino acid in the solution going to change to try to shift towards equilibrium? And so if there are lots of hydrogen ions in solution, the amino acid will pick up a hydrogen ion to try to shift that equilibrium. And if there are very, very few hydrogen ions in solution, the amino acid can donate a hydrogen ion. And so that's the answer to Chapter 19, problem number 23.